All series, Trellis has been catching mistakes at compile time with its analyzers, unsafe value access, the wrong railway operator, a missing guard. But here's the thing, that machinery isn't magic, and it isn't only for the framework team. You can write your own analyzer for your own team's rules and turn a convention that used to live in a wiki nobody reads into a compiler error nobody can ignore. And because an analyzer is just code, you test it like code. Let's write one and prove it works. 3 ideas. First, a convention that only lives in documentation gets violated by a new hire, by you on a Friday, by an AI that never read the wiki. An analyzer makes that convention a build error instead, enforced automatically, in every editor and every pipeline, no reviewer required. Second, these are your rules. Trellis enforces its rules. You enforce yours. Your domain must not reference entity framework. Every command needs a validator, whatever your architecture demands. And third, the part this series cares about. An analyzer is just code, which means it can be wrong. So you test it. It must fire when the rule is broken, and, just as importantly, stay silent when it isn't. Let's see all 3. Here's the analyzer. It's a class that derives from DiagnosticAnalyzer, and it carries a descriptor, the rules ID, team001, a human-readable title, the message it'll show, a category, and a severity. We've made it an error, so a violation breaks the build, not just warrants. We declare which diagnostics it supports, and then, in initialize, we register a callback. For every name type the compiler sees, run our check. And that check flags any type in a domain namespace that touches entity framework. That's the whole guardrail. 40 lines turn, please don't put EF core in the domain, into a rule the compiler enforces for everyone, forever. Now we test it with the Roslyn testing SDK, a Microsoft package, not Trellis. We handed a snippet of source, a domain type that imports entity framework and holds a DB context, exactly the thing we've forbidden. Notice that curly brace markup around the type name. That's how the SDK marks the exact span where we expect a diagnostic, location 0. Then we say, running this analyzer over that source should produce our team001 rule at location 0. Run it. If the analyzer correctly flags the violation, the test is green. This is how you prove your guardrail actually catches the thing it's supposed to catch. And here's the test people forget. The one that keeps your analyzer from becoming everyone's enemy. A guardrail that screams at correct code is worse than no guardrail. People just suppress it. So we write the negative case. Clean domain code, no entity framework anywhere, must produce no diagnostics at all. If your analyzer fires here, it's broken, and this test catches it. And if you went further and wrote a code fix, one that moves the offending type to the ACL, the SDK tests that too. Given the broken source, applying your fix must produce exactly this corrected source. Fires when it should, silent when it shouldn't, and fixes what it can, all under test. So why is this worth a whole episode? Because it's the highest form of the testing idea in this whole series. You're not just testing your code. You're encoding the rules your code must follow and enforcing them mechanically. Write your architecture down as analyzers, and correctness stops depending on whether the right person happened to review the pull request. Test both directions. It fires on a real violation, and it stays quiet on clean code. So the guardrail is trustworthy enough that nobody disables it. Ship it inside your solution, and from then on every developer and every AI assistant writing code against your repo is held to the same rule automatically. That's the dream this whole channel is built on. Compiler-enforced guardrails, including the ones you write yourself. That's how you write your own guardrail, a Roslyn analyzer that turns a team convention into a compile error and a pair of tests, one proving it fires on a violation, one proving it stays silent on clean code, so the rule is enforced and trustworthy. It's the same philosophy Trellis is built on, now pointed at your own architecture. One episode left, and it's the big one, mutation testing, where we finally answer whether your test coverage means anything at all. Subscribe, and I'll see you in the finale.